This video is section 1.10, our last section of the chapter, and we're modeling with functions, so we're doing word problems. These examples are all in your textbook, so if you want to follow along in your book, you can. Go ahead and read example 1, modeling long-distance carriers, so I want you to go ahead and read that example. So, we want to express the monthly cost for plan A, f of x, and it looks like for a function for plan A, we're going to have to pay 5 cents per minute, so 5 cents per x plus the $20 flat rate. Part B, we want to express the monthly cost for plan B as g of x. Now for B, it looks like we're paying a little bit more. We're paying 10 cents per minute, but only a $10 flat rate. No, I'm sorry, a $5 flat rate. Plus 5. Now, the last thing, when are these two going to cost the same amount? So I want to know, when are they going to be equal? In order to find where they're equal, let's go ahead and just set those two equations equal to each other. And now, you can go ahead and solve for x. So we've got 15 equals 0.05x, and if I divide, I'm going to get 300. So after 300 minutes, those two plans are going to cost the same. Example 2. Go ahead and let's take a look. We're talking about an airline that carries 6,000 passengers per month. They each pay $200. If I increase the ticket price by $1, we're going to lose 100 passengers each time. So for part A, I want to write the number of passengers in terms of the ticket price. Now, the thing to think about is, first, what my ticket price is. My ticket price is X dollars. Now, if I take my ticket price, X, and I subtract the $200, that's going to be how much I've increased by. For example, if I want my ticket to be $205, 205 minus 200 would give me a $5 increase. Remember, for each of those increases, I'm losing 100 passengers for each dollar of that increase. So now my function for how many passengers I'm going to have 6,000 passengers, but I have to subtract 100 passengers per increase. And the increase is X minus 200. That's how many dollars I've increased by. Now, I can do a little work here and distribute. And if I combine like terms, it looks like I get negative 100x plus 26,000. And that's going to be my function. Now, the next part, part B, wants to know our monthly revenue for the number of passengers. Now, revenue is how much money we're going to get in. Now, to find our revenue, we have to take our ticket price, that's our X value, and multiply it by the number of passengers, and that's what we just found. And we'll get negative 100x squared minus 26,000x. And that would represent our revenue, how much money we make. Let's go ahead and look at another example. This is going to refer to some formulas. So it looks like a machine is going to produce a box, and it's going to cut equal size squares out of each corner and then shape the box by turning up the sides. And we want to represent the volume of the box. So let's think for a minute here. We have a box, and I'm going to cut out these little corners and turn up the sides. That's how I'm going to make the box. Now, I don't know how much I'm going to cut out. It's going to be a square. But I do know that the length of the entire side is 12 inches. Well, if I'm cutting out 2 squares, it looks like the side that's folded up is going to be 12 minus 2x. So the volume of the box is going to be 12 minus 2x. Remember, volume is length times width times height times another 12 minus 2x times another x. You can think of that as x times 12 minus 2x squared. And if I want to simplify this a little bit further, I could, or we'll just leave it as that for now. Part B wants to know the domain. Now, think about it for a minute. I can't take more than 6 out of each side, because if I take 6 from there and 6 from there on my box, if I take out 6 and 6, I'm going to end up with 12. I'm going to have nothing left to make a box out of. So that means my x's have to be less than 6. My cutouts. So that means it's going to be from 0. And I can't take out 0, so we're not including it, to 6. Let's look at another example here. I have 140 yards of fence to enclose a rectangular garden. I want the area of the garden. So let's go ahead and draw our garden. Now if this side's x and this side's x, that means these two sides combined together have to be 140 minus 2x. But that's those two sides combined. We're going to have to split that in half for each side. And so that's going to give me the amount there, which would be 70 minus x. So our area is going to be x times 70 minus x. And we can simplify a little bit if we want our area in terms of x. 70x minus x squared. Our fifth example here deals with a cylinder that has a volume of 12 fluid ounces, and it can hold, its surface area is 22 cubic inches. So this example 5 has a volume of 12 fluid ounces, which is 22 cubic inches. That's the cylinder soft drink. And I want to represent its surface area in terms of its radius. Now, a few formulas I want you to know first that you might not remember. Surface area of a cylinder, 2 pi rh plus 2 pi r squared. And volume of a cylinder is pi r squared h. Now, we want to be dealing with cubic inches here, the radius in terms of inches. So let's use that 22 cubic inches for our volume. I want the surface area to only have the radius. I want the variable to be r, radius, in terms of the radius. So I need to get rid of the height. So I'm going to go ahead and solve for h in this volume formula. So we get 22 over pi r squared is my height. I'm going to go ahead and plug that in to my surface area equation. Now if I simplify a little bit, it looks like this r is going to get rid of one of those. And we're going have, and the pi's like going to cancel as well. So I'm going to have 44 over r plus 2 pi r squared. And that's going to be my surface area in terms of the radius. Our final example, we're going to inherit $1,600. And we have 2 investments, one for 6% interest and one for 8% interest. And we want to express the interest of the money invested at 6%. So, I know that my x and y together, let's let x is the money at 6%, which means y is the money at 8%. And I know that x and y together is $1,600. Now, my interest is going to be 6% times the money, 6%, 0.06 times the money put in it, and add that to 8% times the money put in y. I only want this in terms of x, so I need to get rid of the y. Now if I go up here and solve for y is 1,600 minus x. If we substitute that below, and I'm sorry, 16,000, we get that equation. Now you could go ahead and simplify just a tad bit. Or you could leave it like that. I'm going to give you one example. Two questions to try. And I want you to bring these with you to class tomorrow. Here's number 1 and number 2.